Good morning, students. We were discussing the chapter on rotational motion, and I hope you remember up to equations of rotational motion we have done. Our today's discussion is a very important discussion, that is the moment of a force which is also known as a torque. I think you might have heard these terms, but I don't know up to what extent you have the idea about it. So try to understand. Obviously, moment of a force or the torque is related to the rotational motion of a body. Alright, I am giving you a simple example. Suppose you are opening a door or you are closing a door. It is always observed that if you apply the force near the end of the door, it is more convenient than to apply a force anywhere nearer to the hinge point, hinge about which the door rotates. I mean to say that the hinge point is there in a door, right? That is acting as the axis of rotation. If we apply the force farther from the hinge point or from the axis of rotation, right, it will be more effective to open or to close the door. It is a simple practical example. So what happens? What is the moment? Suppose this is a rigid body. I am showing a rigid body which may rotate about this axis of rotation. Very clear, axis of rotation is there. It can rotate in any direction. It can rotate. It can rotate clockwise or it can rotate anti-clockwise. Anyhow, it can rotate clockwise or anti-clockwise. Anyway, it can rotate. Then, what is the moment of a force or the torque? Moment of a force or the torque, you can write, moment of the force or the torque is defined as the product of the magnitude of the force. It is defined as the product of the magnitude of the force and the perpendicular distance between the line of action of the force and the axis of rotation. I mean to say here, according to this figure, tau is the notation for the torque or the moment of the force. That should be F into D. I repeat, what happens? I am applying. This is the line of action of the force. This is the point P where I am applying the force. So that it is to be rotated. This rigid body is to be rotated about the axis of rotation. For that, what I will be doing? I will apply a force F at the point P. At the point P. Okay. What is the line of action of the force? This is the direction of the force. If I here draw a line, this whole thing is the line of action of the force. This is the line of action of the force. The direction of the force. That's the line of action of the force. And from this line of action, if I draw a perpendicular or a perpendicular is dropped from the axis of rotation to the line of action of the force. Here is the 90 degree. This angle is 90 degree. It is the perpendicular distance. What is perpendicular distance? It is D. So that's why I have said it is the product of the magnitude of the force and the perpendicular distance between the line of action of the force from the axis of rotation. This is the torque. Obviously, SI unit of the torque should be definitely Newton meter, and I hope its dimension should be ml square t minus 2 if you are remembering the dimensions. This is actually regarding the torque. Alright, it is the torque. Now, torque or the moment of the force. So this is the moment of the force. There are so many applications of this moment of the force in our syllabus also. There are so many practical applications also. But now what I want to discuss in this, that is a very important point, that is the rotational equilibrium and the principle of moments. Rotational equilibrium. Rotational equilibrium, if you compare the translatory motion and the rotatory motion. I just tell you. In the translatory motion, when the body will be in equilibrium, when the net force is 0. In the rotational equilibrium, what happens in the rotational equilibrium? In the rotational equilibrium, net torque will be 0 because force is replaced by the torque. Net torque will be 0. Okay, so rotational equilibrium. So you can write down the statement for this principle of moments. Write down the statement for the principle of moments. What is the principle of moments, right? When a body is in rotational equilibrium, when a body is in the rotational equilibrium, the sum of clockwise moment, the sum of sum of clockwise moment should be equal to the sum of anti-clockwise moment. Sum of clockwise moment should be equal to the sum of anti-clockwise moment. Anti-clockwise moment about that point. Or the algebraic sum, it's like this, algebraic sum of moments about any point is 0. Algebraic sum of moments about any point is 0. I just tell you here, see, this is a uniform rod. In the figure I have shown just to explain this principle of moments. Here, let us consider this is the uniform rod. In the uniform rod, this uniform rod is definitely in equilibrium. If it is a rotational equilibrium, right, that means it will be completely balanced. At that time, it is suppose pivoted, just tika hua hai, pivoted at the point O. At the point O it is pivoted. You might have experienced such type of the things happen. What will happen? On this side, suppose F1 force is acting at the distance d1. On this side, F2 force is acting at the distance d2 from the point, from the point at which the body is pivoted. Then what will happen? What should happen? Sum of the clockwise moment count hoga. This is the clockwise moment and this is the anti-clockwise moment. Look, this is anti-clockwise. You can see the direction. This, if the rotation takes place like this, this is anti-clockwise, here it is clockwise. That means what happens? F1 d1 should be equal to F2 d2. Sum of clockwise moment. Sum, why it is saying sum? Because it is not necessary that only one force on this side and one force on this side. There may be a number of forces on left side and number of forces on the right side. All the forces will be taken into account. But this side, the total moment should be equal to this side, the total moment. That is the clockwise moment, and anti-clockwise moment should be equal. Or you can say F1 d1 minus, look, minus F2 d2 should be 0, which implies F1 d1 plus minus F2 d2 is equal to 0. Algebraic sum. It is the algebraic sum. Algebraic sum means what? What is the difference between the normal sum and algebraic sum? Algebraic sum means the consideration of the sign. Okay. If I consider this positive one as the anti-clockwise, then this will be considered as the clockwise. Look, anti-clockwise will be considered positive, clockwise will be considered negative. और दोनों का जो algebraic sum है वो 0 है. Algebraic sum का मतलब होता है the sum with the proper consideration of sign. Normal sum means no consideration of sign at all. But algebraic sum means with the proper consideration of sign. This is called 0. That means here some of the clockwise movement, anti-clockwise movement will be 0, or this. Both will be applicable. So this is called the principle of moments. It is very much useful. It's very much useful in case of the balance, physical balance. I'm talking about physical balance. You might have seen in physics lab or in the grocery shop. Nowadays, definitely the electronic balances are used, but if you take completely the mechanical balance, which is used by the vegetable vendors and all in the market, so that works on this principle of moments, when it will be completely balanced. On one side the weight is put, on the other side the goods, the vegetables, anything will be put on that. So this is regarding the principle of moments. Okay.